Hi, and welcome to this section of the Pre-Algebra Tutor. And in this section, we're going to study what we call prime factorization, or prime factoring. Again, with algebra and with any subject in math, a lot of the reason why it might seem intimidating at first is just because there are big words and definitions that you really have never used before. So that's the case with this section. Prime factorization sounds like it's going to be really difficult. Well, if you just think about it for a second, we've already learned what a prime number is, and we're going to review that here in just a second. But we've already learned that, so you should feel comfortable with what a prime number is. We've also learned how to factor numbers or expressions. We've learned and talked about the concepts of factoring. So all we're going to do in this section is put the two things together and come up with what we call prime factoring or prime factorization. It's useful, like many things in this class, for a lot of different reasons later on in algebra that you won't truly come to appreciate until you start dealing with more algebra, which we're going to get into later. So for now, just roll up your sleeves, realize this is not going to be a difficult section, and work with me. What we want to do first is briefly review a prime number, and then we'll talk a little bit about factoring. We've already studied these concepts, so we'll do a quick review, and then we'll go and teach you the concept in this lesson. So we want to first recall that a prime number can be divided by itself and the number 1. If a number can be divisible by itself and only the number 1 with nothing else that can be divisible and go into that number, then it's called a prime number. So some examples. This is the same examples we talked about before, but just to give you an idea, primes. These are the initial prime numbers: 2, 3, 5, 7, 11, 13, 17, and you can keep listing these prime numbers on and on. The nice common thing that's common to all of these numbers is that every one of these numbers can only be divisible by itself and the number 1. So, for instance, the number 3 can only be divided by 3 and 1. If you try to divide 3 by another number like 2 or 5 or anything else, you're not going to get a nice even division. You're going to get a decimal. Take the number 11. You can divide 11 by 11, and you can divide 11 by 1, but you can't divide 11 by anything else. So these are the list of what we call prime numbers. We've already sort of studied that. Now 0 and 1, the numbers 0 and 1 that we might think would be primes also, are actually not prime numbers, and that's by definition. So 0 and 1 are just never going to be in your list of prime numbers. It always starts with the number 2. All right. Now let me give you another little definition. And that's just because sometimes on a test you might be asked this. So we have prime numbers. Now a composite number. Sometimes you might see that in a book. So what is a composite number? It is simply all other numbers who are not prime other than 0 and 1. So basically we divide the world up into two kinds of numbers in this section. The prime numbers are listed like what we've talked about in the definition. Composite number is every other number other than the prime number. So everything that you don't see on this list except for 0 and 1, because those are just the special numbers that we start with, and we don't define it to be composite. So this is just a label. It's like something that we list because mathematicians study these things. So, for instance, the number 4 is a composite number because it's not in this list. The number 6 is a composite number because it's not in this list. The number 9 is a composite number because it's not in that list, and so on. I could keep listing numbers out, but you can sort of see that it should be a composite number because all of these numbers can be divisible by other things besides itself and 1. So, for instance, 4 can be divided by 2, 6 can be divided by 2, 9 can be divided by 3. So because we can divide them by another number besides itself and 1, they're not prime, and if they're not prime, we call them composite. It's just a definition. Don't get too wrapped up into this. I'm mainly telling you that because you probably will be tested on it. It's an easy test question for you to get right if you know how to do it. So what I want to do now is basically bust out and tell you what prime factorization is, and that way you get an idea of what it is, and then we're going to work a lot of problems to give you a lot of practice, so I'm going to introduce it for you here. So remember, these are the prime numbers, right? And factoring is basically when, I mean, we did it a couple of different ways, but factoring is basically figuring out if a number can be divided evenly into whatever number you're talking about. So we talked about listing the factors of a number in the last section, all of the factors. And every one of those factors could be evenly divided into the number you're really talking about. That's the definition really of a factor. But when we talk about a prime factor or listing the prime factors of a number, then really the only factors that we're going to care about are going to be the factors that happen to be prime. Now that's a lot of words. You'll understand it with an example. So what I want to do is